Hello. Today we are going to work through the complete solutions for the Cambridge IGCSE Mathematics Core Specimen Paper 3. Our goal is to understand the logical steps for each question and identify common mistakes to avoid during your exam. Our learning objectives are to provide complete work solutions for all questions, identify and avoid common exam pitfalls, and apply IGCSE formulas correctly. We will be using the standard IGCSE formula sheet and following the official instructions, such as rounding non-exact answers to 3 significant figures. Let's get started with the first set of questions. Let's start with question 1, which involves interpreting a pictogram. In part A, we are told Kira sent 15 messages. Looking at the pictogram, Kira has 3 full circles and 1 3/4 circle. To find what 1 full circle represents, we divide 15 by 3.75. So, the key is that 1 circle represents 4 text messages. Now for part B, we look at Hannah. She has 2 full circles and 1/4 circle. Since 1 circle is 4 messages, we multiply 2.25 by 4. Hannah sent 9 text messages. A common mistake is miscounting the partial circles. Always check if a symbol is a half, quarter, or 3/4. Next, question 2 asks us to write down all the factors of 68. A good strategy is to list them in pairs. So the factors are 1, 2, 4, 17, 34, and 68. A common mistake is missing the number itself, or 1. Every number has at least these 2 factors. Moving on to page 4, we have a series of short arithmetic and calculation questions. For question 3, we need to apply the order of operations, often called BIDMAS or BODMAS. If we calculate as written, 4 times 6 is 24, minus 2 is 22, plus 1 is 23. That is not 17. We need the result to be 17. Let's try putting brackets around the subtraction. 4 times 6 minus 2 plus 1. 4 times 4 plus 1, 16 plus 1 equals 17. So the brackets go around 6 minus 2. Common mistake: not checking the result after placing brackets. Always recalculate to ensure it equals the target value. Question 4 asks for the reciprocal of 4. The reciprocal of a number is just 1 divided by that number. You can write this as 1 over 4 or 0.25. For question 5, you should use your calculator. For part A, 24 squared is 576. For part B, the cube root of 2197 is 13. In question 6, we deal with negative numbers. More than implies addition. Negative 57.0 plus 63.8 equals 6.8. The highest temperature is 6.8 degrees Celsius. Finally, question 7 is a currency conversion. Since $1 gets you 0.8476 euros, we multiply. 450 times 0.8476 equals 381.42. Lee receives 381.42 euros. Common mistake: dividing instead of multiplying. Think, if the rate is less than 1, you should get fewer units of the new currency. Now we move to algebra and geometry constructions. For question 8, we substitute the value of 18 into the formula wherever we see a letter T. Let's break this down. 18 divided by 2 is 9. Inside the bracket, 7 times 18 is 126. Then, 126 minus 4 is 122. Finally, 9 multiplied by 122 gives us 1098. Common mistake: forgetting to multiply 7 by 18 before subtracting 4. Always follow the order of operations inside brackets. Question 9 is a construction task. The exam provides a 6 cm baseline. To draw the other 2 sides, you must use a compass. Set your compass to 7 cm using a ruler. Place the point on one end of the 6 cm line and draw an arc. Next, set your compass to 8 cm. Place the point on the other end of the line and draw a second arc that crosses the first. 1. Where the 2 arcs intersect is the 3rd vertex of your triangle. Use a ruler to join this point to both ends of the baseline. Common mistake: drawing the sides with just a ruler. Examiners look for the construction arcs to award marks. Do not rub them out. Question 10 requires careful use of your scientific calculator to handle a complex fraction. When typing this into your calculator, it is safest to use the fraction button. Otherwise, make sure you put brackets around the entire numerator and the entire denominator. Let's calculate the top and bottom separately first to show the steps. The numerator is 13.7 plus 14.02, which equals 27.72. The denominator is negative 0.31 plus 2.5, which equals 2.19. Note that the cube root of 15.625 is exactly 2.5. Now, divide the two results. 27.72 divided by 2.19 is approximately 12.657534. The question asks for the answer correct to two decimal places. We look at the third decimal digit, which is 7. Since it is 5 or greater, we round up the second digit to get 12.66. Common mistake: rounding too early in the middle of a calculation. Keep all digits in your calculator until the very final step to ensure accuracy. Now, let's look at question 11, which tests your knowledge of circle properties. In part A, the line XY touches the circle at exactly one point, R. The mathematical name for such a line is a tangent. In part B, the line PQ connects 2 points on the circumference, but does not pass through the center. This is called a chord. For part C, we are given the area and need the radius. We use the formula area equals pi times radius squared. Rearranging to find the radius, we divide by pi and then take the square root. This gives approximately 3.72 centimeters. Finally, part D asks for the circumference of a circle with a diameter of 6.4 centimeters. The formula is circumference equals pi times diameter. This gives 20.106 centimeters. Wait, the question asks for the answer in millimeters. Multiplying by 10, we get 201.06 millimeters. Rounding to three significant figures gives us 201 millimeters. Common mistake: forgetting to check the units. Always look at the answer line to see if a conversion is needed. Question 12 focuses on a stem and leaf diagram, which is a way to display data while keeping the original values. Here we have the scores of 27 students. The key shows that 2 bar 8 represents a score of 28. In part A, we need to find the range. The range is the highest value minus the lowest value. Looking at the diagram, the lowest value is in the first row, 28. The highest value is in the last row, 62. Subtracting these gives us a range of 62, 28, which equals 34. A common mistake is just subtracting the leaves, like 2 minus 8. Always combine the stem and the leaf to get the actual number first. In part B, a new student is added, and the new range becomes 38. We need to find the two possible scores. There are two scenarios here. Either the new student has the new lowest score, or the new student has the new highest score. In scenario 1, if 62 is still the highest, and the range is 38, then the new lowest score must be 62 minus 38, which is 24. In scenario 2, if 28 is still the lowest, and the range is 38, then the new highest score is 28 plus 38, which equals 66. So, the two possible scores are 24 and 66. A common mistake here is only finding one of the two possibilities. The question asks for both, so always look for how the gap could expand in either direction. Question 13 involves a travel graph. These graphs show distance from a starting point over time. In part A, we need the average speed between town A and town B. Average speed is total distance divided by total time. From the graph, town B is 20 kilometers from town A. Jason reaches town B at 10:00, having started at 09:00. Jason's average speed is 20 kilometers per hour. For part B, Jason is at town C, which is 30 kilometers from town A. He needs to get to town D, which is 50 kilometers from town A. We know speed is distance divided by time, so time is distance divided by speed. Since 1/3 of an hour is 20 minutes, the time taken is 1 hour and 20 minutes. To complete the graph, Jason leaves town C at 12:00. Adding 1 hour and 20 minutes means he arrives at town D at 13:20. A common mistake is forgetting that the vertical axis represents distance from town A, not distance traveled in that specific leg. Always subtract the coordinates to find the leg distance. In part C, a horizontal line on a travel graph means the person is stationary. There is one stop between 10:00 and 10:45, which is 45 minutes. There is another stop at town C from 11:30 to 12:00, which is 30 minutes. The total stop time is 75 minutes. For part D, total distance from A to D is 50 kilometers. The total time is from 09:00 to 13:20, which is 4 hours and 20 minutes. To three significant figures, his overall speed is 11.5 kilometers per hour. We continue with part E of question 13, which introduces Lisa to the travel graph. I. Lisa leaves town C at 11:02 and arrives at town A at 13:42. Draw the line. I. Find the distance from town A when they pass each other. For part 1, town C is at a distance of 30 kilometers from town A. We plot the start point at 11:00, 30. Lisa arrives at town A, which is distance 0, at 13:42. We plot the endpoint at 13:42, 0, and join them with a straight line. For part 2, Lisa and Jason pass each other where their two lines intersect on the graph. Looking vertically at the intersection point and then across to the distance axis, we can see they pass each other at a distance of approximately 16 kilometers from town A. Common mistake: misreading the timescale. On this graph, each small square represents 6 minutes. 13:42 is 7 small squares after 13:00. Now, let's look at question 14, which deals with the net of a cuboid. In part I, we find the volume. The volume of a cuboid is length times width times height. Volume equals 6 times 4 times 5, which is 120. The volume is 120 cc's. In part 2, we must show the surface area is 148 square centimeters. A cuboid has 3 pairs of identical faces. Area equals 2 times 6 times 4 plus 2 times 6 times 5 plus 2 times 4 times 5. Area equals 2 times 24 plus 2 times 30 plus 2 times 20, which is 48 plus 60 plus 40, equaling 148. This matches the target value. In part 3, calculate the total length of the edges. A cuboid has 12 edges, 4 of each dimension. Total length equals 4 times 6 plus 4 times 4 plus 4 times 5, which is 24 plus 16 plus 20, totaling 60. The total length is 60 centimeters. Common mistake: in part 3, students often count only the edges visible on the net. Remember, you are calculating for the 3D cuboid. Question 14. Part B moves into algebraic geometry, asking for the perimeter of a net in terms of variables. To find the perimeter, we need to sum all the exterior edges of the shape shown in the diagram. Let's count the segments carefully. Looking at the top and bottom flaps, we have 2 horizontal segments of length x. On the sides, we have the vertical segments of length y and the vertical segments of the main body, which are x minus 1. By tracing the entire outer boundary, we find the perimeter consists of 4 segments of length x, 4 segments of length y, and 4 segments of length x minus 1. Now, we simplify the expression. The simplest form for the perimeter is 8x plus 4y 94. Common mistake: including internal lines where the net folds. Perimeter only refers to the outer boundary of the flat shape. Next, question 15 uses the sphere formulas from our list. For part A, we use the formula surface area equals 4 times pi times radius squared. Divide 177 by 4 pi. Take the square root. To 3 significant figures, the radius is 3.75 centimeters. For part B, we use the volume formula 4/3 times pi times radius cubed. Use the unrounded radius for accuracy. This gives us 221.43. To 3 significant figures, the volume is 220.1 cubic centimeters. Common mistake: forgetting to cube the radius in the volume formula. Many students accidentally square it because the area formula uses a square. Question 16 covers ratios, percentages, and compound interest. In part A, we have a ratio of Joe to Mira of 7 to 15. Mira pays $84,000 more than Joe. We need to work out each payment. In a ratio of 7 to 15, the difference in parts is. We are told these 8 parts represent $84,000. Divide to find the value of one part. Now, multiply this by each person's ratio. For Joe, 7 times 10,500 is 73,500. And for Mira, 15 times 10,500 is 157,500. So, Joe pays $73,500 and Mira pays $157,500. In part BI, the total profit is $56,000. Joe received 12%. We need to calculate how much she gets. For Joe's share, we calculate 12% of $56,000. Joe receives $6,720. In Part B, Mira receives $14,000. We need to calculate the bank account percentage of the total profit. First, find out how much money goes to the bank. 56,000, 6,720, 14,000 equals 35,280. Now express this as a percentage of the total profit by dividing 35,280 by 56,000, then multiplying by 100. So 63% is put into the bank account. In Part B, Mira invests $14,000 at 2.4% compound interest for 4 years. For compound interest, we use the formula. Final amount equals principal times the multiplier to the power of time. A rate of 2.4% gives a multiplier of 1.024. The value is 14,000 times 1.024 to the power of 4. This equals approximately 15,393.15. Rounding to the nearest cent, the value is $15,393.15. A common mistake is using simple interest instead of compound interest. Simple interest adds the same amount every year, whereas compound interest adds a percentage of the new total. Question 17 deals with prime factors, highest common factor, and lowest common multiple. N equals 2 to the power of 4 times 3 squared. Part A, work out the value of n. Part B, find the highest common factor of 120 and n. Part C, find the lowest common multiple of 120 and n. In Part A, we simply evaluate the powers. 2 to the power of 4 is 16. 3 squared is 9. N equals 16 times 9, which equals 144. For Part B, to find the highest common factor, it's best to write 120 as a product of its prime factors as well. 120 equals 2 cubed times 3 times 5. Now compare this to n, which is n equals 2 to the power of 4 times 3 squared. The HCF takes the lowest power of every common prime factor. For the factor 2, the lowest power is 2 cubed. For the factor 3, the lowest power is 3 to the power of 1. HCF equals 2 cubed times 3, which is 8 times 3, giving 24. In Part C, the lowest common multiple takes the highest power of every prime factor present in either number. For 2, the highest power is 2 to the power of 4. For 3, the highest power is 3 squared. For 5, the highest power is 5 to the power of 1. LCM equals 2 to the power of 4 times 3 squared times 5. LCM equals 16 times 9 times 5, which is 720. Common mistake, mixing up HCF and LCM. Remember, the factor is usually smaller than the numbers, and the multiple is usually larger. Next, question 18 is about sequences. Part A. Find terms A, B, and C in an arithmetic sequence starting with 7 and ending at 31. Part B. Find the nth term of 4, 11, 18, 25, 32, and show that 361 is in the sequence. In Part A, to go from 7 to 31, we add the common difference 4 times. 4d equals 24, so the difference d is 6. Now add 6 repeatedly. A is 7 plus 6, which is 13, B is 13 plus 6, which is 19, and C is 19 plus 6, which is 25. For Part B, the sequence increases by 7 each time. The nth term formula for an arithmetic sequence is the difference times n, plus or minus a constant. 7 n minus what equals 4. If we plug in n equals 1, 7 times 1 is 7. To get 4, we must subtract 3. In Part B2, to show 361 is in the sequence, set the formula equal to 361 and solve for n. 7n equals 364. N equals 364 divided by 7, which is 52. Since n is a whole number, 361 is the 52nd term of the sequence. Question 19 requires calculating a combined mean from two different groups. To find the mean of the whole group, we need the total score of everyone divided by the total number of people. We cannot just average the two means. First, find the total score for the adults. 12 adults times 43.25 equals 519. Next, find the total score for the children. 16 children times 30 to 9.75 equals 636. Now, find the grand total score. 519 plus 636 equals 1155. Finally, divide this by the total number of people, which is 28. Mean equals 1155. divided by 28, which is 41.25. The mean score for the 28 people is 41.25. Common mistake: adding the two means and dividing by 2. This only works if the group sizes are equal. Since there are more children than adults, the children's mean should carry more weight. Now, let's look at question 20, which is a speed conversion. Luca walks at 5.4 kilometers per hour. Write this in meters per second. We need to change kilometers to meters and hours to seconds. 1 kilometer equals 1,000 meters. 1 hour equals 3,600 seconds. Step 1. Convert kilometers to meters. 5.4 times 1,000 equals 5,400 meters per hour. Step 2. Convert hours to seconds by dividing by 3,600. 5,400 divided by 3,600 equals 1.5. So, 5.4 kilometers per hour is exactly 1.5 meters per second. Common mistake: multiplying by 3,600 instead of dividing. Remember, you travel a much smaller distance in 1 second than you do in 1 hour, so your number should get smaller. Question 21 tests your understanding of circle theorems and trigonometry. We have a circle with diameter PQ and point R on the circumference. The angle at P is 32 degrees and the chord PR is 6.2 centimeters. Part A asks for a geometrical reason why angle PRQ is 90 degrees. Part B asks us to calculate the length of PQ. In Part A, we are asked why the angle at R is a right angle. This is a fundamental circle theorem. Any triangle drawn from the diameter to any point on the circumference will always form a 90-degree angle. The reason is, the angle in a semicircle is a right angle. In Part B, since we now know that triangle PRQ is a right-angled triangle, we can use trigonometry. We know the side PR is the adjacent side to the 32-degree angle, and we want to find PQ, which is the hypotenuse. The trigonometric ratio that links the adjacent and the hypotenuse is cosine. To find PQ, we rearrange the formula. Using a calculator, PQ equals 6.2 divided by 0.8480, which gives 7.3109. To 3 significant figures, the length of PQ is 7.31 centimeters. A common mistake is using sine instead of cosine. Always label your triangle sides relative to the given angle before picking a ratio. Finally, we have question 22, our last question, which involves a real-world application of Pythagoras' theorem. A ladder of length 5.6 meters rests against a wall. The bottom is 1.5 meters from the wall. We need to calculate the distance from the top of the ladder to the base of the wall. The wall and the ground form a right angle, so we have a right-angled triangle. The ladder is the hypotenuse. H squared plus 1.5 squared equals 5.6 squared. Rearranging to solve for H2A, we get 5.6 squared minus 1.5 squared. Calculating these values, we get 31.36 minus 2.25, which equals 29.1. Take the square root to find the height, which is 5.3953. To 3 significant figures, the distance is 5.40 meters. A common mistake is adding the squares instead of subtracting. When you are finding a shorter side, you must subtract the square of the known side from the square of the hypotenuse. That concludes the work solutions for this IGCSE core paper. I hope this helps you prepare for your exams.